Welcome to Scaling Up, the podcast for water treaters by water treaters, where we're scaling up on knowledge so we don't scale up our systems. Hello, Scaling Up Nation. Trace Blackmore here, your host for Scaling Up H2O. And folks, once again, another episode from questions from the Scaling Up Nation. Thank you so much, Nation, for writing in or letting me know directly what questions you had. And that way I know what shows to bring you. Without that information, you would be listening to silence right now. Maybe you would prefer that, but I'm betting you probably would not. So keep those questions coming. You might be wondering, how do I get those questions to you, Trace? Well, I'm so glad you asked. It's very easy. You're going to go to scalinguph2o.com and you have two ways to get your questions to me. One is you can go to the show ideas page and write in your question. Or two, you can record your voice asking me the question and I will get your question answered on the air. And if I use your voice on the air, I will send you the most amazing Scaling Up t-shirt. You will be the envy of all your friends, and you can get that by sending me your questions via voicemail. Well, not too long ago, I did a show on calibration of meters, and the questions I had were either around how the meters work or what pH actually was. And folks, I don't know what it is, but more often than not, people like myself that teach water treatment make water treatment needlessly overcomplicated, so the people that are trying to get the information don't truly understand the why behind the question that they are asking. I don't know why that is, and not everybody does that, but more often than not, when a water treater asks a water treater another question, the water treater that's answering answers with the intent of the other person to know how smart they are. Well, folks out there in the Scaling Up Nation, you know I'm a dumb guy, and I don't mind that people know that. I've said it on the air. I've got 10,000 listeners. There it is. It's out there. So with that being off the table, I just want you to understand the information that you need to know in order to be a better water treater. And I received several questions, as I alluded to earlier, around the pH meter itself, but then also pH. So what I'm going to do in today's episode is explain pH in a way that will make sense. So if you were to look at pH, what the heck is it? And I was in a class once when somebody asked, what is pH? And the answer was the anti-log of the hydrogen ion concentration. And that was it. That was the answer. And by the way, the person that was asking that question had been in the water treatment industry for about 2 weeks. So again, we don't have to overcomplicate things. We need to make sure we understand the information that we need to know. Now, truth be known, that was a perfect way to answer that question, but it wasn't what that person needed to hear. Now, I bet if you told him that now, based on him being in the water treatment industry for 7+ years, I'm sure he would say, hey, that makes a lot of sense. But at that moment in time, that's not what he needed to hear. Here is how I like to explain pH. Now, I need you in your mind's eye to visualize the pH scale. And we have a line starting from 0, going all the way up to 14, with 7 being in the middle. Now, most of you out there in the Scaling Up Nation know that 7 is neutral when it comes to pH. A lot of us don't know what that means as neutral. So I'm going to explain that for you. So again, you have to have this visual in your head where you're going from 0 all the way up to 14 with 7 in the middle. Now, water is H2O, 2 parts of hydrogen, 1 part of oxygen. We're now going to rewrite this, and if you've had organic chemistry, you always write water as HOH. H. It's the exact same molecule. We're just writing that a little bit differently. So here's what I want you to visualize. That long line that has 0 on one end and 14 on the other end with 7 in the middle, and then right above 7, you've got HOH. Now, this is what that means, and this is what we mean when we say neutral. When you have a pH of 7, it means you have equal parts of hydrogen ions and hydroxyl ions. Now, hydrogen's the H, hydroxyls are the OH, hydrogens are the positively charged, OH are the negatively charged, and we have equal parts of them at 7. Now, we might have 20 billion H's at 7, but that means we have 20 billion OH's at 7. So that's what we mean when we say that it's neutral. And of course, water is neutral because it's just hydrogen and hydroxyls, and we have equal parts of them. Now let's explain pH based on that. Now we're going to start moving further and further away from 7 down to the 1. And we all say, well, hey, the lower the number is in pH, the more acidic it is. Well, here's why that is. The further you move closer to 1, or away from 7, the more hydrogens you have in the sample. Hydrogen, sometimes called the proton, that is what acid is derived from. And the more you have of hydrogen, the more acidic it is. Now, so much when you get all the way to the end of the pH scale, all you have is hydrogen, and that gets into some of the superacids that we have in chemistry. Now let's look at the other side of that. The further we move up the pH scale, so away from 7 but moving towards 14, the more basic or the more caustic, those are similar terms, the sample gets. The more OH concentration we have in the sample. And if you start looking at your bases, you will see that they are all made out of OHs. So if you get all the way up to the 14 range, again, those are supercaustics in chemistry, and all you have are OHs at that range. So that is what pH is measuring. It's measuring how much or how little hydrogen is in the sample. So the lower we go, the more hydrogen we have in the sample. The higher we go, the less hydrogen or more hydroxyl we have in the sample, and then that's where we get pH from. That being said, I heard someone answer the anti-log of the hydrogen ion concentration. Again, a perfectly acceptable answer, but not until we got some more information. So it said the log of the hydrogen ion concentration. Well, log is just a big fancy way for us to say times 10. It's times 10 of the hydrogen ion concentration. So at 7, remember I have equal parts of hydrogens and equal parts of hydroxyls. Well, now if I go from 7 to 6, I have 10 times more hydrogens at 6 than I did at 7. If I move down to 5, I have 100 times more hydrogens at 5 than I did at 7, and I keep multiplying that number by 10 until I get all the way down to 1,000,000, which means there's just all hydrogens in that sample. Well, let's start at 7 and go the other way. So if I start at 7 and go to 8, I have 10 times less hydrogen ions than I did at 7. If I went up to 9, I have 100 times less hydrogen ions that I did at 7. Remember, pH is a measure of the hydrogen in the sample, but we can also look at it because we know what pH is telling us now, that when I go from 7 to 8, even though there's 10 less hydrogens are in the sample, I have 10 more hydroxyls in the sample. Remember, that's the OHs. And then if I move to 8, I have 100 times more hydroxyls in the sample. All the way up, when I get to 14, it's 1,000,000. It's all hydroxyls. So I hope you can visualize that, because if you can understand that, that is what is going on with pH. And so many people will look at a sample and maybe they're cleaning a system with acid and it's supposed to be at 4 and they see it at 2 and they say, oh, well, that's no big deal. It's only 3 numbers off. Well, that's a huge deal. That's 1,000 numbers off. There's so much free hydrogen in that sample. Whatever you're doing, you got 1,000 times more than what you were told that you need. And sometimes that cannot be a good thing. So that's what pH is. Now, when you press pH on your meter, what your meter is doing, it's measuring how much hydrogen's in that sample. And then, this is where we get the 7 from. If we were to look at the decimal points of all of the graduations of pH, 0 all the way up to 14, when we're at the 0, it's a 1. Everything in there is hydrogen. When we get to 1, it's going to be 0.1. 2 is 0.01. Notice 1 decimal point for 1, 2 decimal points for 2, all the way up to 14 decimal points at the very end of the scale. So that's where we get that pH range of 0 to 14. And what's in the middle of that? Well, that's 7. And now you know that a pH of 7 is equal parts of hydrogen and equal parts of hydroxyl. Folks, I hope that helps you understand a lot more than when I take a pH reading, I'm simply jotting down a number. You now know what that means. Now, all of the products that we use are based on that range of pH in which they work the best in. And then that's why it's so important that we are staying within whatever ranges your company says that that particular product has to stay in that range. If you have ever taken my course at AWT's Technical Training, you know that I talk about one of the 5 ingredients of scale is pH. If you're wondering, it's calcium hardness, it's alkalinity, it's pH, it's temperature, and then all the dissolved solids in the water. Well, as we increase pH, the more susceptible to scaling we become. As we reduce pH, the more susceptible to dissolving scale the water becomes. So again, I hope that this helps you understand pH. And I want to thank everybody out there that asked me questions around pH, and I sincerely hope that this helps. Folks, if you have a question and you want me to answer it on Scaling Up H2O, go to my website, scalinguph2o.com, go to my show ideas page and leave me that question. Or you can record your voice on the voicemail button right there on the homepage. And if I use your voice on the show, I will send you the most amazing Scaling Up H2O t-shirt. Folks, thank you so much for being part of the Scaling Up Nation, and I'll talk to you next week on Scaling Up H2O.